So, starting a bit early today. And let's see. I actually got some good stuff done the last day or so. I think the coolest bit being that I made improvements to the test harness that I started last week. And so now actually deving today is going to be a lot faster. So instead of deploying to the headset constantly and taking the headset on and off, like I'd already had some improvements around that thing, but it still meant deploying to the headset. And I'd figured out, with the HUD and things like that, I did make it easier. But even beyond that now, I have it so we don't even need the VR headset. So all we have to do is make a change to the C++ code, build the Windows library, and then run Godot normally. And that'll just pop out a window on the local machine. It will fail to start VR, but that's fine. We don't need that. And if it is that scenario, my code auto detects that we're in that kind of test case scenario, and it now runs test cases. So I started building out test cases. Here's the most recent result of one of them. And oh, by the way, it's faster. Since it's using the local GPU on the Windows machine, it's a lot quicker. And so now I've got, actually, let's see here. I've got test cases here in my test file, and I give them names. And actually this one, I'm gonna rename this one. I wanna start using like tags. Let me see here. Darn, what do I want to call it? Because it has like two issues with it. The one issue is, I guess I should name it. So align frames is the one issue, and then crop. We'll call it crop page one. Let's call it that. So those are the two issues with it: aligning frames and cropping page one. And so if we look at this content, is it not going to? Why is it not showing them? There we go. So you can see, like, I think it was because the headset was running a little slow, or there was some sort of issue where I think the frame rate, the frames per second, the FPS on the VR headset dropped because of something I was doing. And so normally it would have taken, you can see that we've got 5 frames we're taking. And it normally would have taken them like a half second or so to grab all 5 frames. But you can see the distance between this one and this one. I mean, I'm reaching down because I thought I was done. I thought I was done capturing frames. But this ends up being actually a pretty good test case. And so I actually after I ran this and got an error and it didn't work out right, and I pulled the files off of the VR headset, I decided like this would make a good test case as part of the test suite. And I'm going to improve this test suite, probably not today, but I'm going to improve the test suite to the point where I can actually run these on CI/CD and have it all run on the terminal and be super fast. So that way I can just make a code change, click a button, or run a single command on the command line, and then go right back to coding while a bunch of test cases run in the background. So this is one of them. So you can see we've got the images are far off from each other, which they shouldn't be. They should almost look identical is what we want, because we want to grab frames that are either maybe not adjacent, but like 2 or 3 frames apart for each of these. And so since it should all be occurring in less than a half second, the frames should all be very similar, and they're not. The other issue is there's a bit of bleeding where it's grabbing the monitor in the background and saying it's part of page 1. And so that's the other bug I need to fix, which is why I'm calling it align frames, crop page 1. Those are the 2 issues for this test case. If we look at the results, so we'll see again, I brought in those 5 images. So you can see pretty good, pretty good. Because of the way the code operates, this middle frame is the one that we say is the good one. And then we try to take the 2 frames before it and the 2 frames after it and merge them all together. That's wrong. So that's template frame is that one. It's not supposed to be that one. It should have been this one. So I'll have to go look at that. we can see in the morphological results that the monitor up here got detected as a text region, and it got included as part of this. This is bad. So when we do the bounding box, I can tell you just from experience doing this with OpenCV, what it's going to do is we will cut a bounding box off here because there's the white. We're looking for the two largest regions. So the two largest regions are this one and this one. For this one, the furthest left that we are is here. The furthest at the bottom we are is actually down here. These two little strips that it detected. So it'll crop from down here. The highest it'll be, since this tied in, it's actually going to go to the top of the picture and say that we should crop up to here. And then the furthest right, again, it should be here. This is where it should be. It should stop it here. But it's because it says that all this data is a part of the biggest blob, it'll actually crop to here. And so we end up then getting part of page 2 as part of this crop. So I need to tune it to cut this off. And as part of tuning it to cut this off, I'll probably end up cutting off a little of the bottom as well, but that's fine. The right side is not too bad, right? We end up getting a little bit up here, right? So this ends up, the crop will end up being taller than it should be, but otherwise page 2 ends up being just fine. And so we can see that when we crop, we end up getting the whole height here. We get part of page 2. Things come down a little bit. Not great. Here's the other, well, actually, yeah, here's the other bug is cropping page 2 is broken. So actually, let me add that. Crop page 2. I'm going to make these keywords this way. The reason why I'm going to do this is I'm going to be able to then filter on these. So I may, if I get enough test cases, I may get it to the point where I want to say, hey, only run test cases where the phrase align frames shows up in the test case name. So that way I can then filter down. Let's say I'm just working on something that only affects alignment issues. If it only affects alignment issues, I only want to run those test cases. So if we go back to this, yeah, so for whatever reason, and this happens every time, and I don't know why, that shouldn't be the case. It shouldn't be cropping. It's like cropping like this, when it really should be a tall, I would expect a tall crop that includes up to here. So that's the other issue I need to investigate. Yeah, and then somehow template for alignment. I don't know why that is. And then when we try to align these frames, when we try to take, what's supposed to be happening is we're taking this frame and saying these should all align to them. And if they don't align well enough, we should be throwing them away. And that would be a good thing, right? If this image is too far away from this image, throw it away. We don't want it. And when we throw it away with different errors. So that's what the names of these files are. So this one, it said it's throwing it away because ECC alignment failed. Okay, fair enough. This one said translation too large. Okay. This one said good alignment, which I guess maybe is this one. So maybe these two were similar enough that it was able to align it. Maybe. And then this one was too dissimilar, which is good. Should have thrown it away. But we still end up with, like, it probably should have thrown them all away. Like, we should have ended up with just this image, and then all of them were thrown away because none of them are similar enough to align well. But we ended up keeping one, so we merged two. And then, as you can see, when we try to align them, we end up with, you can see the spine here cutting through. But at least it's better than it was, because I already started fixing this bug, I think the previous run. Nope, that one's just as bad. Where is it? No, this one looks just as bad. I think I was still... Or maybe this one might have been worse. Hold on. Yeah, no, this was still me, like, running things over and over again. No, this was a good run. Oh, yeah. Oh, this one worked. Oh, you know why? Because I got it working. But then I tried to optimize the code, and that caused problems. Here we go. So this is what happens when it doesn't do a good enough job of throwing away all those frames. Like if it tries just merging them all, it's bad. Anyway, so that's what we're working on today. Let's see here. So our goal is to OpenCV text cropping in... Is it text cropping? No, that's not what we're doing today. Image enhancing. Image enhancing in Godot. So last time we pulled in the C++ code, that was fine. We tested it and confirmed it still works. We fixed some bugs there. Integrate with image merging, we did that. All that seems to be pretty good. And then the question was, hey, do we implement dewarp and deskew? And then are we done with C++ for now? Those two are still true. I still want to decide whether or not I even... Like, I should be able to just implement dewarp, deskew. So, fix alignment bugs. Fix cropping bugs. Fix those two bugs. Implement dewarp, deskew. I think we still probably want to try that. I don't know. That's an open question. If we do a good enough job of fixing alignment and cropping, we may not need dewarp, deskew. I do think we need to error on bad OCR. So the one thing my test harness doesn't do right now is we're not running OCR as part of it. I did improve the OCR so that when it finishes, we compute a distance. And where does that look like? That is... Yeah, here at the top. I finally got the actual proper perfect text for my test page, for the test page that I'm going off of, this specific page in this book. So this is the exact text, exactly the way it is. And when we run it, when we run OCR Manager, when we run Tesseract, and we finish, I think it's happening in the C++ code, actually. Yeah, calculate frame similarity. No, actually, that's frame similarity. What am I talking about? GD log. Oh, see, now I have a lot of log statements. One moment. Hold on. Oh, here we go. Yeah, so this is the right now it's just a log statement. So I do have a method here that computes how similar text is from each other. I don't know how accurate this is. Is it going to, how noisy it will be? But at least I'm able to get a percent score. And I think the last time this ran, I was getting around 56%. And that's still with some of these bugs in place, right? Where we still have some bugs I need to fix. So my goal then is to get it so I can run the entire battery of test scenarios. So every edge case I run into on the VR headset, I can dump those images, throw them in a folder, and then outside of VR, outside of the headset, just be able to run every single one of those scenarios through, it actually will run it in Godot, but then we'll call the GD extension, do OpenCV, do OCR, get back the text similarity score, and then have it so as long as if the score drops below, drops by more than 1%, throw an error. And so then that way I can make quick code changes, run it against 10 scenarios in under a minute, and immediately know whether or not my code change had a bad impact or not. So this should rapidly increase my testing speed. So I want to error on bad OCR. At least implement that. I may not implement a full CI/CD pipeline yet. I may not get it to... We'll see. Today I may do that. I may get distracted and say, hey, can I just create a shell script where I run the shell script and it does the build of the Windows DLL, and then calls Godot from the command line, and then shuts it down when things are done, and then gives me back an error report. I don't know how much energy I want to put into that. I don't want to go that crazy, but we'll see. Okay, so like fix some bugs. At least let's throw an error when our similarity is bad. And I might just make that hard-coded for now. Like just set a threshold of 60%, an error if we drop below that, and then as I keep improving quality, just keep improving that threshold and expect that, that's probably easier for now. Like no test scenario should be below like 95% would be the goal. Implement dewarp deskew, and then hopefully we're done. All right, let's go with that. See where the wind takes us though. So we'll run that in the background. All right, let's get into it. So my current issue is, let's get back to the folders. All right, so the issue I'm still having, the issue I was focused on for the moment, was that it's doing bad alignment. Meta, you need to stop nagging me. I don't want you to nag me. Leave me alone. Oh. Huh. Exit. Go away. Thank you. Okay, so it's merging. It's still doing bad merging. No, Meta, go away. I don't want you. I didn't ask for you to keep yourself open all the time. I do want to fix this cropping issue. And I do want to fix, well, and part of fixing this cropping issue is, well, actually no. Fixing the morphology issue will fix this. We'll fix the fact that we're getting too much from the top and bottom and that we're getting too much to the right. But that doesn't, this bug seems to be different. Like this is way off. This is something more fundamental. Like the bounding box is not even going off the bounding box info. So I'll have to figure out what that is. But I want to fix this first while the scenario is bad. Like these are, actually, do I need to? Because it's going off the cropped images. Because it is cropping, right? That's our problem. So it's... Because even if I fix the cropping issues, I'm still going to have a problem with the alignment. Okay, I may be chasing ghosts then. A little bit, if I try solving this issue right now. Let me switch gears and let's see if we can fix... This is a more fun problem to solve anyway. Cool. So that should be an easy enough fix. Oops. The issue being, what's it called? The power we have to tune this. I gotta delete a lot of this old code. There's a lot of old code in here. We got binarization, crop center. Where's my methods? Or maybe I'll look at the .h. Maybe it's that. So we have our frames. Okay. So we get our frames. We detect our bounding boxes. I could log this out and see why our bounding boxes are bad. Oh, well, so detect bounding boxes. This is actually the thing that I want. That's where our problem is. So detecting our regions. Here we go. And here's our settings. But when we do the cluster regions morphologically, so, okay, there's two groups. I mean, I can fudge with some of these settings. Well, let's try it. Switch that to 10. Let's run that. I'm not going to worry about trying to like auto run Godot just yet. I do want to get there though. It would be nice to like do a single command, kick it off, and know that it'll not only do this build that it's doing right now, but then also run the test suite. But I'm not going to do that just yet. I may actually want to do some research because I think Godot has some built-in capability for that. Come on, why are you so slow? Okay, that's that. And then if we just run this, I do want to get rid of this pop-up window though. Was requested but failed to start. Yeah, that's going to require maybe a little research because I know where we're doing it. It's... Wow, why is everything going slow this morning? It's in here, right? So we try to XR interface. But maybe this is throwing an error. Yeah, I don't want it to throw a pop-up error. Anyway, there it is, and we should already have results. Like it took like it runs faster on the local machine, so I'm not even going to really use these numbers for performance. That'll be the annoying thing, is to truly boost performance. I'll need to run it on the headset, and then when it's running on the VR headset, anything that's taking too long will be much more obvious. But you can see here, it's like what we're doing the start here at 9,187, and then oh no. Wait, done merge multiple frames. Where's the start to merge multiple frames? Either way, this last step here was 9.8, and we started down here at 9. Like, so it's less than a second. We did everything. So that's cool. Let's go look at the results. Should we like default to extra large? Did that change anything? That seemed to have no impact. Okay. Not terribly surprised. I had already figured out that that was a good setting. What if I go down to 5 on this? I'm curious what that... Like... So I was at 15. I think 50, no matter what I did here, didn't really affect anything. I think this is the setting that we were struggling with. I think this will make it worse. So hopefully it's just a matter of like tuning it up to like 20 instead of 15, and then that solves that issue. Oh, that probably failed, right? Yeah, access denied because Godot is still running. So I do want to... Here, let me fix that though. Godot. Force app shutdown. No, force. No, don't select all. Here we go. Force apps shutdown. Handling quit requests. Most platforms have the option to request the application to quit. Can we do that? So on ready, no, wrong spot. Where is our, oh no, it's the debug HUD. So here's our run test cases. So on ready, we check to see if we're not in XR. For now, this is the way I'm doing it for now. If we're not in XR, then we must be trying to run the test cases. So we run test cases. And you know what, I'll probably just put it here. Let's see how that does. Let me pull that down a little bit. Let's drag it over. Okay, and now let's run it. And hopefully it'll shut itself down when it's done. Cannot call method wait to finish on a null value. Ugh. If thread, maybe that's it. It looked like it did finish, so it just on exit tree it failed because the thread was already done, I guess. Okay. Now let's check that out. Yeah, see, it made it worse, which is going to make the cropping worse. Now we effectively, you can see like the two largest regions end up being everything in the center, hence this image being like literally everything. And then the second largest region's up here in the corner. And that's where we end up, yeah, with this image being like the second largest region. So curious, that seems to be working as expected. I mean, that looks like that would be ending like right below that bit of orange there. And that's so, maybe it is cropping correctly. All right, let's turn it up to 20 and run it again. So definitely knew going in the, I was pretty sure I was heading in the wrong direction there. And then, yeah, not what we want. It should be throwing these out, and it's not. And it's saying good alignment on all of them. I actually had a version of this code that was working really well that I had generated with Claude. And then I asked it to make it faster, and I think in making it faster, the performance went way down. But I think it was taking like 10 seconds. Couldn't have that. Like, it was taking way too long. Access denied? Oh, it killed it, but... Oh, it didn't succeed at killing it. All right, maybe this time it'll work. Nice. And yeah, it died. It didn't hang, didn't get stuck. That's a nice little improvement. And there we go. All right, I'll go with 20 for now. That seems good. As I add more test cases, I'm sure I'll end up in situations where I will tune something to fix an issue in one test case, but that'll break something in another one, which is good. That's a good problem to have, because it'll be nice then to see, as I turn knobs, like where's the threshold between different test cases succeeding or failing. And then maybe at some point there may be certain test cases where I just decide that the scenario is too extreme and I just give up on it. As predicted, so we've isolated up here And we also lost this down here. So we should end up with 2 better crops. There we go. That's like a perfect crop. That's exactly what I want. And then what the hell is going on here? Like, why? That doesn't make any sense. Unless it's getting like rotated somehow. That second crop. Quite funny, quite funny. So we should be going with the first one. So the template, we're using the wrong image for this. Notice how now our template for alignment, we're cropping, like this is, I think this is the one that got used to generate this, but then we're applying that crop to the middle one. I think that's what's going on. All right, let's go fix that. Oh, but by the way, that's pretty good looking, right? So just by fixing the cropping, we like did a good job of fixing some of our other issues. All right, so where is that? We are, our template frame is not that frame. It's not the first frame. Just to ask the question, Godot get middle element of list. And actually, where's our template frame? So this is enhanced text from frames. And I'm telling it which one is the middle index. Where are you called from? You are called from outside. You are called from the outside. So I'll probably add an argument to this. Yeah. Okay. Let's do sorry, where is this? So that way we only have to do it once. And we will do int template frame index. And if we go up here, this is the arguments, right? And we continue on. I'll just make this a required argument and trust it, because I know I'll always provide it. So then I can get rid of all this code. And then our template frame is that frame. So now we just grab the template frame and erase it. But then that means, in fact, I can build this now while I go do this. We need to pass a new argument here, template frame index. Okay, Godot, what's going on? I don't want to click on you, but now I'm going to be forced to. Arrays. Methods. All, any, append, assign, back, clear, fill, erase, get. I mean, I think I know how to do it. I just want to see if anybody has. Yeah, because basically I need to do this. Let's just comment all that out. Cool. So we do want to do, what is it, like frame buffer. I'll just roll it myself whenever. Oh, frame buffer size? Frame buffer size. What is frame buffer size? I don't think I saw that anywhere. We set it to a number. We pass it in. I don't think I'm using that anywhere. We have a getter and setter for it. Yeah, getter, setter, we're not even using it. Let's see here. Yeah. I mean, I'll do that as a reminder. Okay, so I mean, I could use it. Fine, let's do that. And then that way I don't have to think as much. So we now have frame buffer size. Do int, no, var, template index equals, that's an integer. Probably do this. Let me do a log statement. Game state. Let's do game state.log. Test1 plus, I'm just being lazy. So var test1 int equals int of 4 divided by 2. We'll do test2. And we will do 5 divided by 2. What? Oh, plus. Testing math. There we go. I mean, I expect what should, I mean, this, of course this should work. If it's 4 divided by 2, it would be index 2. We probably need to do -1. -1. Let's try that. There's our template frame index. Let's go with that. And then our template frame is that index. In this case, it should be index 2. If this is 5 divided by 2, 2.5, but we integer that to maybe not. Maybe it's just, the problem is if you divide by 4, 4 divided by 2 is 2, but that'd be index 1. So maybe it's that, since this is going to floor, go to floor. Yeah. Anyway, this is why I want to log it. Okay, so now that we have the template index and we pass it in, why are you complaining? You are not supposed to complain. Enhance text from frames. Now has a new method signature. We're passing an integer to it. Where am I seeing that? Yeah, let's go look at binarize. I think I know what I'm missing, but let me just go look anyway. No, it's just an integer. So why is it not happy? We're passing it. Template frame index. I don't have to pass it anywhere else, right? These are default values, if they have default values. Too many arguments. Well, this is probably not going to work, but let me reload the current project, because sometimes it gets stuck. And if I run the test case, it'll probably just fail, but I could try anyway. Oh, now it's happy. Yeah, okay, it got stuck. Cool, let's run it. Don't think this is going to solve our issue. Whoa. What happened there? Oh, because we've got a different template frame. Interesting that it struggled that much. I'm a little surprised. I would have thought it would have still... But see, now this one worked fine. This one didn't. How did it do on blending the images? Not great. We can see one that didn't get merged very well. Which is a little surprising. I mean, I guess, is that the largest area of text? Maybe. I would still think it should. I would think it should still work. Let's see here. Misere. Min area. If I go up to 10 on this, that may perform slightly better for this scenario. Do we have, was it XR server dot whatever. Hopefully, I think when I do some research on how Godot runs, like how you can run Godot from the command line, because I think you can also just call methods from in Godot. Maybe I'll just skip all this altogether and then just straight up call a debug test run thing. So I'm as tempted as I am, I'm gonna skip that for now. All right, and as annoyed as I am about this pop-up, I'm not gonna try to automate everything. Okay. That did worse. Sorry, let's take it to an extreme. It was at 5. Let's go to like 40. And in fact, I'm gonna, oh, come on. Fine, do your thing. Cool. I am going to change this window size so I don't have to click around as weirdly. Okay, and then I can have this over here. Maybe I will reverse it. I'll go over here, and then I'll do window size over here. And then this I can drag out a bit. Enough so that I can just click there. 10:15, right? Okay, so that did even worse. So I'm going in the wrong direction, which means if I go down to like 3 and run it, will I get better then? better, but not great. Let's go down to 1. Heck, let's go down to 0. Let's go crazy. I wonder if I can cache some of this. I mean, I guess it's caching as much as it can, right? It's just doing the compiling. I mean, let's be real. This is pretty fast now for our test looping. It didn't help. Interesting. Hold on 1 second. Let's see here. Do I have... Nope, this is the wrong thing. This is reading room. This is code I don't care about anymore. Now, here we go. This I do care about. Where do I have... Why is this doing this? Why are you being weird? Okay. I think it was the page was loading. It wasn't too happy. Here we go. Not gonna like that, but it's fine. Let's do... Didn't ask you to autocomplete. Here we go. Okay, so delta, if I increase it, less sensitive to small variations. Avoid huge regions. I mean, I'm not going to say it's going to do anything, but what happens if I bring that down? Because things further away may be more likely to get clumped in as a bigger region, and therefore that may successfully like kick them out. Whereas the book may always be like pretty reasonable. Let's try that. Hey, didn't even notice somebody posted like an hour ago. If you're still hanging out, hi. Appears to have no effect. I mean, if I go to like 20 on that, like what's it gonna do? Like what's the lower limit on it? Is really what I should do. I should tighten it up as much as possible until I see things breaking and then double its value and leave it there. All right, what about these other ones? So more restrictive on variation, but I don't really know what that means. Okay, that doesn't seem to have mattered at all. So I got down to like 10. More diverse regions, diversity. And that is min diversity. I'll take that down to 0.2 and we'll see what that does. I think that started to hurt us here, but I can't be sure. Let's go back up to 100 for it. That max area doesn't seem to have any effect, really. Less evolution steps. So this is probably going to boost speed, but at some point it'll reduce quality if we lower that number. Mid margin, edge blur size, less blurring. Yeah, I'm not really sure what that did. What I need here is not the morphology. All right, let's do Control Z. It's not the morphology step. Where's my log statement? Morph. Got like multiple morph steps. Probably need to consolidate them. Yeah, I think this one's not even used at all. This one is another one that's used. Here we go. Cluster regions. Let me grab this. I think let's do detect text regions. Okay, but that is going to be all right. I need to add so we got regions, P boxes, detect regions. I need to add this here. And that is looking for a mat. How did I do that before? Let's see here. Debug. Okay, so I think I need a copy of the image, and then I can do this. We detect regions. Right, so this just could happen sooner. Okay. Can I do this then? Shoot. Here we go. Oh, I do have image. Okay, so I should be able to do here we go. So I should be able to do what? CV mat debug image debug image equals image dot clone, and then I need a for loop example. Specifically this example. Like literally that exact example. All right, there's our for loop. Region and regions. And then we'll call this measure regions. And let me search for that again. Let's go up to its definition. Right. Here we go. And I just want to wrap this whole thing. Just, if I end up having to do this a lot where I'm taking something like points like this and I want to send them out as an image for debugging purposes, then I'll abstract this out into a method and call it. But for now, I think this will be okay. Do we have convex hull somewhere? We do. Here we go. So there's our hull. So what we do is we define hull. And then we take our regions and we generate a convex hull from them. Do we have a reshape example? All right, let me do this. Below is some Python code for OpenCV. Please convert to C++. I don't need header files or anything. I have all of that already. I just need to see how this particular logic translates. Please and thank you. There we are. Yes, yes, yes. You have your explanation. I don't need your explanation. Okay, so we have our image clone, debug image for const auto, region and regions. Got you. This is a point. Regions is a point. I think this can't be a point 2f. That's got to be a point. So we're doing a vector of CV point. And then we should be able to just call on it. Okay, I guess I thought maybe it would have to do the reshaping, but I guess the reshaping doesn't matter. That's good to know. So this step's done. And then standard vector hull points. std, and then this is CV, hull points. And then we have our debug image that we want to do polylines to. Standard. CV. There we go. And then I don't need any of that. And it seems happy. Okay. If not, but if it is enabled, clone the image, do all the things, do the polylines, and then emit the image as a file. I think I need to see this because I need to see what it's saying are regions, because it's not detecting those regions. I think that's the problem. So in theory, this just works. And then if I come back over here, yeah, it's finished. Let's run that. Error, no error. It didn't like it. Why didn't it like it? If I run it again, that's weird. What if I do not? And then run this. Does it just then succeed? Oh. Why is that there? Fine. Maybe... It's so interesting, like, what will constitute a build failure and what won't. What will just result in a runtime exception. So I'm guessing, like, the entire file was invalid. And I don't know how I can see that. I mean, I know for... If I'm running it on Android, on the VR headset, I can do an ADB command to see the raw logs and see what's going on. I don't know how to do that on Windows just yet. So that I could detect an error like that. I'm guessing that's what's causing it to fail, is that quick little typo. Does it get further this time? No. Still just as unhappy. What if I comment it out? I'm going to guess that this will work. Let me go see it. Yeah, it worked. And the previous one didn't, right? Okay, so it doesn't like it. Let's see if the AI has any thoughts. Below is the final method I have. The only new code is the code we just worked on together. Let me ban you. There you are. Everything builds fine, but it's failing at runtime. You see it's failing to run. It's failing to call the method. It's failing hard at runtime. Let's just call it that. Do you see any issues with this code? If I set, let's just paste that there. Let's rip this out. I love how it always complains about commented out lines of code. If I set, if I toggle, then it works fine. Found the issue in you're passing regions, the center vector of all regions instead of region, the current. Found the issue in the convex hull calculation. So it should be convex hull region. Okay, so it was a typo. It's just a different typo. So annoying. Yeah, I didn't need the whole code change. Just tell me the bug. Yeah, there you go. There's the bug. Also, adding CV to polylines. Fine. I mean, that's a good call. All right. get an output. There we are. This is what I want to see. So this is why we're getting like a scatter here. So I can improve that. And the way we improve that is by messing with these values here. So I seem to recall, yeah, if I go down to like 2 or 1 there, maybe if I go down to 0, it skips it. So let's just take it down to 1. Because I could have sworn the mid area was the thing that was going to improve it. Game start. No? It's probably that pop-up is hidden in the background. There we go. There's our folder. And no, not really. Let's see. All right, let's go previous on the left. Or, yeah. Are we detecting more? I think we are. You can see, like, here versus here. So we did get a few more flakes of stuff. But I'm guessing not enough to do more than just a bit more noise in here. But if I drop the threshold on this, that might do better. But really, it's this. This is the problem. Okay. If I go down to like, let's go to 3 on that. I think if I go to 8, no, actually 8 would probably make it less sensitive. Yeah, let's see what it does. Because I would still think in this scenario, it should do pretty well for detecting text. I don't know why it's not detecting text that well. The book isn't that far away from the camera. Oops. There we go. So now it detected a bunch of more things. But it also detected some stuff in the middle there. And we're back to, now we've got like this problem up here again. So now it's going to say that the largest region is up through here and over to there. It's going to end up capturing the whole book. No, it's not, because... Really? It should have like gone all the way over to here. Is there like a sliver of a line? No, that's connected there. So it should have... Yeah, either way. So that's that issue. Okay, so this worked. If I go down to 4, is that just enough to sneak one past the goalie on this one? Let's try that. Because I don't want to go 3. I think 3 is too sensitive, if I remember this from before. Did that finish? Yeah. Yeah, still pretty good at detecting text, all that got really well detected. And now we've got this blob here. And what's it going to say? Is it going to say this is bigger than that? No. It's saying the top is bigger. So then this is where... Yeah, I could probably mess with more variation, more settings there, but... This height. If I go to... Let's double it. See what it does. I think that'll make it worse. I think we'll get more sparse results, I think is what'll happen. Yeah, much more sparse and pocketed. This will end up being the largest region because it's very interconnected. This is not. So we don't want that. Get down to 30 on that. Okay, and let's see. Well, we did get some interconnection in here. So this ends up being pretty good. I think it's still going to, but that's disconnected there. So I may actually say that that's the larger region, but it didn't. It actually said, it actually liked this more than it liked that. One fix for that, again, would be to tweak this to detect more text. I mean, we should be able to have... I don't know how much I want to mess with this, because I know, like... I don't know, like, it should be working fine for this. Why is it not? Like, it should be able to detect all that. All right, let me think. And again, if I go too low, yeah, actually, I remember having this pretty low. So if I go down on 10, so I went from 30 to 10. Let's just remind myself again what this does. We'll capture that over here. I should just build a neural network that'll coalesce around the optimal values to configure this to, you know, no, let's not do that. Yeah, it bleeds together too much. But it does do a pretty good job of interconnecting. So that was from 30 to 10. Hey, maybe we go back to, you know, where we were before, basically. which I think actually was 15, now that I think about it. I think that's actually where we were at. Who knows? Maybe the original values were in fact the right ones. We just needed to fix some other bugs, like picking the right image to be the one that we connected to. Interesting that it's saying multiple images had good alignment. But look at that garbage at the end there. Okay, that finished. Let's go back. Let's clean up a bunch of these. I'll go up to here. Now, yeah, we're back to that connection issue. Where now it's saying it's all part of the same. So I think to break it in this scenario, that's where we went to 20. 20 was just enough to break it. 50 from side to side. What if we drop that to like 4? Let's go from 50 to 20. And let's run that again. So I went from 50 to 20 on the kernel width. So what we're doing in the wide, 50 to 20. Let's bring this up. And let's run it. Right. That was our problem from before. So again, we've solved the vertical issue. We're not connecting in this up into here anymore, which is good. But now we're bleeding across the center. Right. So if anything, we want to go to like 70. Let's see how that is. And let me bring this up and leave this one up. So this is like 20. So comparing 20 to like 70. So now we're getting a lot more sparseness in there, which is a good thing. Like having it as one big blob, we do kind of want a little bit of disconnection. And not bad. The only issue is this little blob here. I think it should connect in. And that's going to hurt this blob in terms of how big its size is. Also, like this one's not going to be connected. But, you know, we did start seeing some sparseness. Up here too, again, it didn't break this up too much. I think it actually did break off this whole branch here, which is good to like fragment this up and basically say that it's not part of the same, you know, same here, like breaking that up a bit is good. But I don't think it broke it up enough, right? Yeah, we still detected the top as... So if I go 60 though, that's probably going to be reasonably good. I may go back down to 50 where it was at, but that might be roughly the best we can do. And now if I run this, What do we see? Better. Still some disconnections. This is disconnected in here. That's disconnected, which is good. If I compare this to like the first one of today, so this is where we had that problem. What about this one? Yeah, no, like we're not. These are all from like a few minutes ago. But either way, this is one where I know, like, just changing that one setting, we were able to disconnect it. But yeah, you can see like this is disconnected, but it should be connected in. I think this is a different page though, technically. Yeah, it's a different page of the book. All right, let me go slightly. Let's go 55. Like, let's see. That's just a little bit of the limits of it, right? So, no wait, this is the old one. We want to go with this one. So that's our little scatter plot. What we should see is it start looking like a more big form blob. Ready to run? No, still building. There we are. There's our folder. Better. You can see now like this blob here got interconnected. So this one got connected in. And then these weak connections are now stronger. Was it enough though? No, it's still detecting the top. All right, I'll just go back to 50. I think 50 was good for a reason. This one I changed up a little bit. It's a little bit higher. Yeah, I think our only option is so frustrating. I mean, it is this image, and it's saying that this region here is larger than this region here, which just doesn't seem right to me. How are we determining the largest regions? Let's look at that. So we detect them. Sample regions for oh, actually, yeah, hold on. So we have that, and we just get them. We're not being picky. We're not overcomplicating it. Grid sample regions. We have our target regions is a count, is a number here. What is that supposed to be? We're not passing that in. Huh? What? How is that not failing? Right, target regions. I think we had set it at like 5,000. So this is where you gotta test things, because the AI is not going to translate it well. So this needs to have a default. I can hard code that. I don't care. Let's do an int target regions equals 5,000. I don't know why this isn't being passed in, but it's not. Oh, okay. It's getting defaulted up here. Fine. Okay, fine. I'll let you have it. All right, so it's getting defaulted in the .h file to 5,000. So if we have less than 5,000, just return them. So this is just to downsample us. And how are we doing it? We're doing it on some sort of algorithm. Per grid? Oh, right. Right. Grid sample regions was a bug. All right, let me... I'll continue to use this one. Please explain what this code is doing. To reduce the number of detected regions while maintaining good spatial distribution across the image. Here's what it does step by step. Purpose. If too many regions are detected, more than target regions, this function intelligently samples them down to avoid clustering and ensuring regions are spread across the entire image. Early exit. Grid setup. Calculates how big each grid cell should be. Divides the image area by target number of regions, then takes square root. This creates a grid where each cell can hold at most one region. Calculates the centroids of each region using grid assignment. Maps each region's centroid to a grid cell. Only keeps the first region that lands in each grid cell. This prevents clustering and ensures spatial distribution. One issue with this code is it sometimes works too well, where I'll end up with too few regions. And that worsens the quality of later steps. What are possible ways to improve this? Please explain. No code yet. Here are several approaches. Set a minimum threshold, at least 70% of target regions. If grid sampling produces too few regions, fall back to a different strategy like random sampling or density-based sampling. Start with the calculated grid size. If it produces too few regions, iteratively reduce the grid size. Stop when you reach an acceptable number of regions. Prioritize by area, convexity, or some quality metric. This maintains spatial distribution while increasing region count. Analyze spatial distribution. Hierarchical sampling. Geez, there's a lot of approaches here. Okay. Okay, what if we let's try implementing option 3, allowing 2 regions per grid, where I can change that setting to 3 or 4 later if I need to. Cool. So we have our regions per cell. Just grid calculation. Gotcha. Okay, so we're just factoring in this number here. That's cool. Grid size doesn't change. Grid, the looping doesn't change. Perfect. Nothing else changes. It's like grid key. Grid.find grid key. Gotcha. Grid key equals. Okay, so we want to do. We're doing this. This is a change. Where's grid? Okay, grid is more complicated now. I understand. Most of it doesn't really change too much. We get our integer pairs, check our size. And then when we sample regions, for const pair, auto pair grid. And okay, so it's a nested for loop now. Gotcha. And we're going to up it to 2. Heck, I don't care about performance, so let's go 5. and see how that does. See if that like moves the needle in any way. And before I run that, it's probably this image here. I think we're doing the filtering after this though. Yeah, that looks the same. That looks the same. Wait, didn't we? Thought we fixed that. Yeah, so this probably changed because of the grid. Because of the grid size. Otherwise, it seems to have no impact. We do have some like tighter coupling in here, tighter connections. I don't know. What if we go to 15? This might not be as bad as I think, because in deeply clustered sections, we would still cut out a lot, potentially. So I'll take it to the extreme, and then we can measure performance later. I'm so far thinking that this does nothing. Yeah. Yeah, I don't think it's really helping. And the problem... All right, let's undo it. We don't need the extra complexity. Okay, let's go back to that. So in theory, this is like taking a sampling and chopping them down. And then we do clustering. So the problem being, when we come into this clustering, we have fewer to work with. Now, one thing I could do. All right, let's just run this again as is, so I can get a baseline. Because the clustering does get us this the morphology. Morphology image, debug image. So what I could do, our grid size, we get the minimum value of the number of regions dot size. So this is taking gotcha. Okay, I don't want to mess with that value. Because if we're below 5,000, yes, just be done. I don't think we are, though. So what? GD log. Well, okay. I got a couple things I can mess with here. Let's run this. Let's get our baseline, and then we're going to keep this baseline around for several tests while we narrow down what effects we can have. So here's our baseline. Our baseline's doing pretty good, right? This blob is not connected in. It would be nice to connect this piece in and these little disparate ones to make this stronger. But otherwise, it is what it is. If we bring this down to like 2,000, no, 10,000. Let's go high. And we're basically saying let's let more regions in, even if it's going to hurt performance. I had set it to 5,000 for a reason, because I really was trying to. We were getting like 50,000 regions, and we wanted to cut that down. I think I did go down to around like 2-ish, and it didn't really help. Like, it made things worse, and 5,000 seemed to be pretty good. But if we're below 5,000, we do that chopping up, and we end up with a bad result. So if I just up that, and we just let more in, now all of a sudden we have that connection issue again. And our problem is, again, I think our problem is, again, we're detecting a lot up here, but we're not detecting these. So we're not getting enough regions. That's still our problem. If I improve that, that'll probably solve our issue. Yeah. I also need to add a 5,000. Let's go back to 5,000. Let us, oh, by the way, so we just have vector of points here. And what we end up with is sampled regions. Okay. And this is where we end up with regions too. So actually, let me do this. Let me cut this out. Where is this called from? Let's move this here. And let's move this here. We have image.clone for both. And then this is going to be sampled regions. Let's do that, and then we'll do just so they're different. Okay, now we're getting an image. We'll log an image after this step, because this step is the one that's going to heavily impact morphology. And oh, by the way, how many regions are we getting, in fact? do gd log found regions plus int what is it, regions dot size as a function, and then sampled regions down to filtered regions down to. Let's call this filtered regions. Just to keep our code nice and clean. Okay, so now we're going to add extra log statements. We're going to know what the sizes of these groups are. We're going to have extra images to look at. We've reset things back to the way they were. Our new image should actually be identical to this one, just about. Okay. Now, run that. And are they identical? Yeah. Yeah. We're back to... It is nice that it's reproducible, whatever that function's doing. I think at one point I had it doing random sampling, which is fine, but at least this is reproducible where I get the same result every time. Okay, so we've reset ourselves back to where they were. We have this one, and then we have our filtered down one. And I don't think we're filtering at all. 287. Oh, shit. Oh. Okay. Hold on. Did I not see this before? Operating this on this many regions. Hold on. That's down here. That's after clustering. Got you. Okay, maybe I jumped the gun a little bit there on my woe. This log statement's not working. I think it's failing. I think because we need regions to be like that. And yeah, of course, I can't make this an integer. It has to be a two string. All right, now we'll get it. I wonder how small this is. I guess it is a bit of a double-edged sword, because if the majority of the regions we detect are in the top of the image, yeah, we may just hurt ourselves. All right, what do we end up with? All right, so we found 6,000 regions. And now we're down to 1,600. So now, if we... That's a problem. Grid size divided by total cells divided by 2. If I just do that, just make the grids a little bit smaller, that should increase our number. And again, it should still solve our density problem, where if in a given grid we have like a tight clustering of things, we still just want one from that grid. But this should then also help us when we go do the morphology checking, that we still bridge those connections between those, effectively those adjacent grids, right? If the grids are too sparse, then we may have that decoupling problem. So this should help us get a clearer... Yeah, this should help, I think. Really? Was this the 1128? Okay, yeah, this was just now. Okay. What are our logs saying? Filter down to 2,000. So that did help. That got us more. And the proof will be here. Like, you're not really going to see it in this image, because it just means that there's like a whole bunch of teeny tiny, like, I don't know, maybe you could see it, but you'd have to like look closely and see, like, are we filtering something out? I don't really see us filtering them out, but we are. We're losing. We end up filtering things out, which is a good thing. Oops, did I close that folder? I did. Testing. Test results. But the result here, let's go smaller now. Let's go 3. And see what that does. I want to at least get us up closer to like 5,000. But this gives us another knob to turn. And let's call it, actually, let's do like int grid size setting equals 3. Let's do that. Eventually, I may want to like pull variables like this up to the top of the file, so that way I can quickly adjust them. And then I obviously then more clearly know what levers I can pull to improve quality. By the way, yeah, what did our log say? 24. That wasn't that much more. I don't see much of a difference here. Let's go to 10. Let's just go small. And see what it does. I mean, because we are, like, we're dividing it and then we're doing a square root of it. So width times height divided by cells, which is a min value. So that's a shrunk value. It's gonna be like 5,000, or it's gonna be, yeah, in this case it'll be 5,000. So height times width divided by 5,000. So we're talking like 1920 by, what's like 780 divided by 5,000 divided by whatever weight I go with, and that's our grid size. And then how is grid size even used? Yeah, divide by grid size, grid key. Let's run it. That had an effect. Wow, only like 3,700. So, hey, at least it's a powerful setting. I know I can actually like, kind of fine tune it. And now this is where we got into this problem here. So let's go 20. Let's turn two things at the same time. Let's go 10. 20 and 10 on those two settings that are right next to each other, which is nice. I can actually like, keep them in the same view here. And yeah. So now I should be able to be more aggressive on the kernel setting. We went 20 and 10. We kind of like flip those values, yeah. 1134. All right, that made it worse, right? I think we wanted to go the other way. Let's go 30 on this. And we'll leave this at 20 for now, the grid size. So that should have filled in a lot of the blanks, and now we can be more discerning. This should make it more sparse, I think. Sometimes I forget. By the way, how many did we find? 4,000. So we're getting diminishing returns a little bit on how much we shrink those grids. But I think this is good. I think this means that like if the book is really, I think what this really means is if the book is very close to the screen, or if the scene is just super busy with lots of stuff going on, that we're gonna put a cap on it. So if this ends up being 50,000, like we're still, I'm actually curious what it would do if this was 50,000. Would we still end up around 4? Like how good would it be? Yeah, that ran, right? Okay, there we go. Now we're back down to like kind of sparse. But that's good. That's good in a way. Let's take this down to 25 now. And I think our 4,000. I don't know. I'll take that up to 40 in a second, just to take it up to its limit and see what it does. Finish. Here we go. Yeah, that was fine, I guess. Not too much of a difference. 4,000. Let's take this up to 40. And yeah, it seems like if I take this up to 30, things bleed. But if I take this up, that may also cause things to bleed, which means then maybe this number can come back down? Maybe? Question mark? Finish my coffee. Switch into water. All right. Yeah, what did it do? 4,500. I'm gonna call it there because I know like any larger. I mean, I guess. What if we went? Actually, did I see that? If we go to 7K on target regions there, just let them all through, right? Then we'll just short circuit. We'll skip that whole step altogether. And maybe I want to do that for this scenario. Yeah, maybe I want it to be 7 instead of 5 anyway. Let's leave this up. We'll go up a directory. Use, bring that there. Bring you down there. Let's tighten things up a little bit. All right, and if we run that. Yeah, what do we get? Oh, well, right, we let them all through. So yeah, all of them got filtered in. All of them got included in the filtering. And it didn't really affect things any. I mean, we were all ready. Oops, yeah, here we go. We were already pretty well tuned at that point. This got connected in. This little sliver here, for whatever reason, just still doesn't want to connect in. Which is fine. This connection over here got bigger. Okay. So our issue is we're not getting enough regions, really. I think what I'll do, I'll keep this at 7,000 for now. And then this, if we go above 7,000, then I want to chop down more aggressively. So we'll set that to 30. So for lower quality images, we will skip out early. And then if we didn't filter, we'll still keep it pretty large. Okay. Now back up to here. And if we take max evolutions down, that should boost speed. I wonder what it does to the quality. And the way we're going to look at that is through this image. So we'll peg that to the corner. We should see a drop. And our measurement is going to be, so 6,500 basically. Do we get 6,500 or do we get a lower number or something? We got the same. Interesting. So that seemed to have no effect, which was not what I was expecting. What if I go the other way? Max evolution. I don't know. Let's go 500. So if I run it now, it should take possibly even noticeably longer. Still found the same number. Yeah, I mean, it looks the same. Okay. So this maybe matters in other areas. Our margin. Let's go from 3 to 9 on that. I'm just going to mess with these settings until I start seeing a noticeable result. I did have delta at 5 before. I wonder if I take it back up to 5, do we start seeing something interesting? Maybe that was it. No, I think 4 should have gotten us more regions. I don't know. Let's find out. Let's see what wacky thing this does. I'm going to keep this window up. Since we're just running over and over again, I just need to see the logs. Same number of regions. So again, I shouldn't be seeing any impact. It seemed like it just didn't matter. Let's go back up. Let's go to 6 on delta. And what does that do? That's definitely going to do something. I wonder. Less sensitive to smaller variation. Less sensitive, you say? Well, this should be more sensitive. Now we found fewer regions. Regions dropped heavily. Here, let me clean up again. Yeah, now look at it. Oh, I deleted the frame that I was looking at. Darn. Okay, well, anyway. Yeah, we got it found a lot less. It still found these though. All right, let's go the other direction. Let's go to 3. And maybe that will help us find that small text, knowing that that's the thing we care about, and then looking for more of the density, so be a little more forgiving with what we count as text. Maybe that's the game. But then we filter by region, Then we can isolate those regions. Yeah, maybe that's it. Yeah, we want to... Yeah. Yeah, I think before I was playing the game of trying to limit the number of regions we were getting. And that's where I was doing random sampling, which random sampling would get it done. Oh, Nelly. We got 9,000 regions. So that worked. That found a lot of the page. And now we're interconnected. Like that little offshoot here got clustered in. And yet, we still identify... Actually, yeah, this is just... Something's wrong here. I gotta figure out the cropping. Yeah, that region there. Okay. So 3 was good. I don't know. What if we go like 9 on blur? What is that going to do? You know, I could be smart about this and do... Or I can do even better than that. Let's just run this one more time, and then I'll actually ask in a Claude what these settings are, and that way I'm not stabbing in the dark, actually. Okay, 9,000. Yeah, still 9,000. What were we talking about here? Yeah, so that worked well. That worked well. Taking a look now at my settings. Can you explain what each setting does and what would be good setting changes to try to improve what I'm detecting in these images? Okay. So my current is, yep, minus the fact that it's not 5 anymore. Delta, stability threshold. A region must be stable across this many intensity levels to be considered maximally stable. Roughly speaking, it's the relative variation of region area when intensity changes. Okay. For text, try 3 to 8. Lower value is more sensitive, which is going to get more regions. I think I'm doing 3. Yeah. Min area 5. Minimum region size in pixels. Very small, good for small text. Yeah, I don't know how much better I would do at that. Quite small, may miss larger text blocks. Yeah, I think I had it at 200 before. Maximum area variation between extremal regions at varying intensity thresholds. Moderately strict. Max variation. Try 0.25 to 0.75. Lower is going to be more stable regions only. Fine, let's go 2.5 on that. We'll test that in a moment. Diversity. Allows more similar regions. Maybe I should take that up. Because shouldn't the regions be different from each other for text? Like they would all kind of be a little bit scatterbrained. Well, let's see what this did. Whoa, we dropped our region detected. But was it a good thing? Yeah, no, we've gone back to... Again, we're still finding all that. So what if we go the other direction? Like, this could be good. So if I change the max variation, but then we up delta as well, that may balance out in some interesting way. I mean, I think this case is fairly typical for this kind of image. So I do want to see if I can kick out noise in the background. $11,000, so we found more regions now. Found quite a bit more regions. But now we found a bunch of other stuff. But, you know, it's okay. I think it's okay if we have all these little pockets of things. Because based on the clustering I'm doing now... Oh, yeah, look at that. So now, actually, the question is, did it identify this as the biggest region? And for whatever reason, it's still saying top center is the biggest. Oh no, it made a connection there. Okay, so I need to fix that. Let's keep that variation at that level. And let's go to what, 45 here? And then yeah. We don't need to change vertical at all. So that may, we can't have this connection here. That's not good. And by the way, by breaking this, we may break up something else, which could help us. Here, I'll keep this off to the side. Let's go back. Build is finished. So now we got 11,000. Now we're down to 8,000. So I do actually want to reduce that. So we'll change that other setting in a moment. which also may help disconnect things a little bit. Yeah, that stayed the same as expected, but we should see no change. Huh. I would have expected a bit of a change. Okay. Let's go lower on it. Or was it higher? Ah, I always forget. Fine, let's do that. The other change I want to make is... Oh yeah, let's drop this down to like 20. Let's drop the amount of things we get, because we want to be below. We want to actually try to get down around 5,000. Because I know that text is going to have good clustering anyway. So if we can get that down, other things in the background will drop out a little bit. So this should take us down to... I think that did affect it a bit. I don't have the old log. I meant to keep mental note of where that was. Okay, so that made things worse on the interconnection side of things. Which means... let's go to 60. And then this... where is it? Where are you? Here we go. Let's go to 10. Let's make those grids a little bit bigger. And both of those together should actually kind of help things a bit. I didn't really want to be spending today futzing with tiny little settings. Just, I don't know, it feels like it should be easier to fix this than maybe what I thought. But I feel like I'm close. I don't know. All right, now we're down. Yeah, we dropped our number back down to 11. Well, still 11 something, 6.4. What's our new result? What is going on? I feel like I'm not having any impact with these changes. Let's go down to 1. Let's go to 80. I don't know. And we were at 11,500 for regions. It is installing it, right? I didn't get like an error. Yeah. So 11,500. Same? Weird. But that had an effect. Okay, so that actually did a decent job of like disconnecting things. Okay. Possibly a little bit too much. But, Okay, and then what's the rest of the result? Right, now left page is now the biggest page. And then we're back, so we're back to the right page sucking. I'm gonna leave it like this for now. I need other test scenarios to run before I can feel confident about it. Let me switch gears and see if I can fix this second cropping issue. And oh, by the way, how is this looking? Better, right? Because now we are... Middle image is good, and then we end up with... So this is our template. And then, which means like we're cropping down this. And when we do that for this first image, we're getting the bottom of the page as expected, too dissimilar. The second one should have also been too dissimilar. I don't know why it wasn't. Hold on. Too dissimilar, low correlation coefficient. Okay, we're not, I didn't log everything, right? Right, so low correlation. That's our missing image. So that basically means, so this whatever, one of the, well, yeah, the first one was, this one was too dissimilar. This one had low correlation. So it wasn't too dissimilar, which is odd. Like, even though these two images to me, like these two, actually I should be able to do this, right? I guess by virtue of just being slightly over, it like put it close enough to like pass that first check, but then it failed the correlation. And then the next one was too dissimilar. And then the last one was too dissimilar. So it rejected all of them, which I guess that means because we did a good job of cropping down to just the text, when we try to align something like that, we're like, whoa, it's too dissimilar, which is good, right? Like, what I want to see is, like, I probably maybe need to be like slightly more generous on the padding left and right. Yeah. Not sure there. In any case, template good, dissimilar, dissimilar, dissimilar. So we end up just keeping the original image, basically. And that's why this looks so good. All right, but why is the second one cropping terrible? Let's look at our cropping logic, shall we? So I should draw an image so we can visually see what it's planning on cropping. Detect bounding boxes. Detect regions, found regions, right. So we did the clustering. Right. So we have an array of all right. Let's have the AI help me, so I don't have to worry about this myself. Start a new chat. I have the below C++ code with debug images I am writing out for myself so I can visually see what is happening. Can you add that debug logic for the last step in the code below? Yeah, generate different colors. Good. That's exactly what I wanted you to do. Oh. Really? Well, that's a... boo-boo. Right. Okay, well, maybe I'll just... I don't know. What did the AI say? Do I like what it said? Fine. I don't like providing names like that, but it's okay. All right. So then we have our use different random colors, use slightly thicker lines, make them more visible, follow your existing pattern of cloning the original image and drawing on top. This will help you visualize. Cool. So it's this if block. I am really gonna have to clean this up, but that's okay. We will do a tab. This should work. All right, let's see how it looks. And I guess it should be, yes, it's gonna be one image with multiple boxes on it, which is what I wanted. Because my instinct was like, I guess I could just loop over it and do a different image per one, but I'd much rather see it all in one image. Fantastic. And I didn't want to waste my brain cells trying to figure that out myself. And there we go. So, what's the bounding box going to look like? Clustered regions, huh? Here it is. Okay. That's good. I like it. All right, fine. Works great. Thank you. Here is the code right after that code. Can you add a debug? Can you add debug logic for this step as well? Okay, so we have our array of result. Ew, really? You're gonna do it out there like that? And then within the for loop for each cluster. Oh, okay, fine. Get the B box, dictionary of it, append. Fine. I really hate this now, but I'm willing to live with it for the moment. So then we have a result. And this all got messed up. Tab that over. Where's our bounding box image? That's our mat over here. Okay, and then final step is outside of all that. Perfect. Now I'm going to ask it to like abstract it out to functions, so I can just call those functions. Okay, and how are we looking? So again, 11, 3,000. I think that's okay. 3,000 is fine. These are the regions for the cropped images, which is fine. All right. Performance is decent, so I'm willing to live with it for now. Hey, here we go. Okay, so that's working, right? That's exactly what I wanted too. That looks great. Even put like a nice little cute little number in each telling me what they are. All this looks good, so then why the F is this cropping like that? So oops. You know what, let me ask it this. Perfect. Finally, comma, I have debug methods that are below. Can you refactor the above code so that the business logic doesn't get distracted by all the debug logic? That then gives me debug methods I can call wherever I need to. Can you refactor the above code? Sorry. And abstract out the debug logic, the debug code, so that the business logic doesn't get distracted, doesn't get cluttered by all the debug logic. That then gives me, that also gives me debug methods I can call wherever I need to. Okay, and then for that, here is my GD logger. feel like I lost that method. Where did that method get to? Oh, it's above GD logger. Here's a refactor that abstracts the default logic into separate methods. Debug draw filtered regions, debug draw clustered regions, debug draw bounding boxes. Your clean business logic now looks like this. Yep, we can do filtering, and then we call that method. Do clustering, call that method. Everything's nice and tight. Feels a little gross because we have what? Our base image. This is a vector. Convex hull. I mean, you could do another abstraction in here to like take this for loop and make it a call to this. I don't love this, but it's better. I need to keep this logic, and I'd rather have it than not have it. So let's pull it up. And then we're going to go down to the bottom. With all this ugliness. I think it is grid sample regions. Grid sample regions. So now I've got this logic back. I don't need this cluster region step, right? That's what the log statement's for. The log statement, which serves as both code comments and also log statements all in one. And if we're running in production, those logs don't happen. Starting to feel pretty tight, actually. Okay. Now I need... Okay, there's our signals. So for each of these, I need those represented. So let's put that there with a semicolon on it. And we can kill that. Do I want this? Sure. Is it going to be happy with that? Maybe, maybe not. Okay, so that's all I needed to do. It seems to want to align them on the paren. Fine, I'll do that. So Shift Tab, let's get that over. We can Kill that. Does that ring true? Yeah, it still wants to. Fine. That one's solved, and then we got like one more left. Yep. All right, we're back to happy. Let's run this one more time. And I am way overdue for pushing code to GitHub. I need to do that. I'll probably end the stream soon here, but I definitely need to do that. And not forget to do that. Because I've made a lot of changes. Let's check that result. And everything's still looking good, right? There's our bounding boxes. There's our image. This is still broken. Cool. Yep, all looking good. Okay, so now that we're back to clean reading logic, let's go with, where's that used from? Cool, so this method now is still pretty tight with business logic, couple of lines for logging and debugging, but nothing that distracts too much. So we draw our bounding boxes. We call it bounding boxes. So that is this. Those are correct. The bounding boxes there are correct. Let's put that over here. And that's our clusters. Result. Oh, right. Right, our result is an array. So what do we do with that? Okay, I think I need to go look at this logic then. Because, darn, so we could get the convex hull. Get convex hull for the cluster. Yeah. And then this is drawing lines and such. Not too helpful. But we do have bbox center. So we do have our bbox at center. And then for our lines, we get the vertices. All right, so unfortunately it doesn't translate directly. We get center X, center Y, and we get our width and our height. And then we pass back. So that's our result. So then we have our B boxes. crop image from bbox. This logic probably has a bug. By the way, cropped frames. Right, so we're just taking the first bbox. And we're just saying, hey, go do it for all of them. That's the frame buffer's all of them, right? We're not popping anything off of the frame buffer. Right, so there's a little bit of duplication there. But we're just basically saying, hey, go crop all of those. To be safe, I could... Well, this is actually working fine, right? Because I know these crops are all working well. The issue is just that for whatever reason, the second crop is bad. So we have our center X and our center Y. Add padding around the detected region. Why? Why is this failing? We know the region is good, but yet it's consistently failing. So weird. Like, that doesn't make sense. I'm like actually baffled. Okay. So, Again, this I know is right, because our first bbox is solid. It's our second bbox that's broken. I mean, we could do game state dot log string of bbox of our box. We could do bbox string of I plus okay. Is there anything here I can do? Cluster size, if not cluster empty. I don't care. Like, it's not going to be empty. I mean, fine, whatever. I'll keep it. Get convex hull box. I mean, there's a chance that this is wrong. Well, I can run this real quick. See if we're getting like a bad bbox for some reason. says that. Going twice. Okay. So bbox 0 is the good one. Still have the problem, right? Yep. Its center is 384 by 643. And the center Y on bbox 1 is lower. And that's true. It's ever so slightly lower. Center X is twice the way into the image. Sure, seems likely. The width is 300. And the height is 600. The width and height seem to be reversed for... Ooh, it's detecting an angle. 90-degree angle. Why is that? All right, so the issue has got to be in the get convex hull. Oh, that's why we're calling this 4 times. I wonder if it has anything to do with the size. Because it is dealing with more. And we're giving it regions. Okay, if I go look at my original code... Here's our definition. We have our centroids. And then we loop over the regions. We get a moment. Check it above 0. I do have a check here if centroids is less than 3. I think that would always be the case, right? Oh no, centroids. Oh no, yeah, no. We would never cluster the regions. Hold on. So we just call convex hull. And then we're doing squeeze. That's min area. Rotated rect. bug I'm investigating. I always have specifically two clusters of regions where we have already filtered out all the regions that don't matter. I'm then trying to get a B-box for each of those clusters. Here is, below is the method that does that. Does that. I'm noticing that the first cluster returns with a correct B-box, but the second one is always 90 degrees off. Can you help me find the bug? Here is also some log information for what B-boxes we compute. Here is the code. Where's Godot? Where's my bounded boxes? Min area rect, yeah. It always ensures that width is greater than height. When it needs to swap dimensions to maintain this constraint, it also adjusts the angle accordingly. This can make it appear like some bounding boxes are 90 degrees off when they're actually correct. Your log data shows, yep. That's exactly what I saw. I don't want an angle. The second B-box likely represents a vertically oriented rectangle, but min area rect reported it as a horizontal oriented rectangle. Here's the fixed version. So we still get the centroids as a 0.2f. We do our log statement, we loop over all regions, we get our moments, we do our calculation, we push back on the centroids. We still get our hull as a 0.2f. We call convex hull on those centroids. We then get our min area rect. If you want to keep the original OpenCV behavior but understand what's happening, thank you. Previously, when I prototyped this logic in Python, I had the below logic. I know for a fact that we never want to rotate 90 degrees, and that the incoming text is always correctly oriented, maybe off by a couple of degrees. Is your approach still the best one? No bounding box. If you want the same behavior as your Python code and you know that text is never rotated significantly, you should return an axis aligned bounding box instead. Okay, so again, we do the 4 regions, we push back on the centroids, we get convex hull. Uses bounding box. Okay, so CV rotated rect. We're still returning a rotated rect. Instead of rotated. Gets the axis aligned bounding box instead of rotated rect. This matches your Python behavior and avoids unwanted rotations. Then we create a rotated rect. Convert to rotated rect format. Do I need rotated rect? What if I want to ditch that? Do I need to return rotated rect, or could we just return rect, knowing that the next step is to compute a bounding box? Oh, sorry. Next step is to the next step is returning the bbox information to Godot so that in GD script I can crop the image for these bboxes. You can absolutely return a rect instead. Since you're always using angle 0, a regular rect is simpler and more appropriate. Of course. As I thought it would be. Right. And you'll need to update your calling code to match. Right, so we're going to do CV rect. This is now a CV rect. And this is now a CV rect. That also, by the way, means that we are just going to return. So we're doing the convex hull. That's literally the only change we're making. Get convex hull in our .h file is just going to be a rect. That should be happy now. And then down here, right, so now we just have our dictionary and we just have X and Y and our width. then we don't need angle anymore. What's mad? What are you complaining about? Ah, okay. Simpler, no angles, perfect for cropping, cleaner GD script interface, just X, Y, and width. You can now easily crop with something like, yeah, see, why, this is why you gotta question AI code. Why? I didn't need any of this, you know? Still treat it as a method. Okay, hold on. Let's start with perfect. I actually have some debug logic that writes out a test image showing these B boxes. Can you update it based on us using rect now? I'd be happy to. Here's the updated debug method. Okay, so now we just get a rect with our B-box. Yeah, see, this is so much simpler. Oh no, I've hit my limit until 3 p.m. Oh no, you're almost out of usage. Okay, I got like one more query. It's a good time to go grab lunch, right? Okay, so now I've got I find this always so hilarious. So yeah, I don't have to do the for loop. I'm not drawing any of that stuff. I'm just doing the put text. Right, well the put text didn't change. And then the circle didn't really change. Yeah, we just needed a point. Okay. Let me build that. Last little request. Great. And then finally, I have some GDScript logic to add some padding before cropping. Can you update this logic as well, please? Okay, some out of messages. That's fine. Yeah. Okay. Yeah. Simpler padding logic. Yay. Okay. This is much more simple. Great. Why the complexity? That finished building. Let's run this. And hopefully that solves our cropping problem finally. Invalid access? How dare you? Oh, we still have like center X. Didn't it? Oh, what did it say? Sorry, I probably didn't follow all of its logic. Gotcha, yeah, so it just said X and Y. With width and height. Yeah, because it's not the center X anymore. It's now just like a simpler thing. Let's kill that. No file permission writing issue. Nice. Run it. Did it finish? Let's see now. So there's our just the things we want. There's our bounding boxes. A little bit ugly, but I'll take them. That's why we have the padding. This padding's good. That padding's good. A little bit on the edge there, but that's okay. Amazing. I think we fixed it. So this is like as good as it's gonna get. And yeah, I expect the quality to be bad on that one. So actually, yeah, probably can't do a like expect all these test cases to score 95 because this one's like set up to fail because the raw images are bad on it anyway. And that's what makes it a good test case as well. So I would need some other metric to determine. All right, I am shipping this like right now. And in fact, I may even decide that this pull request is done. Let's add our source files. Well, let's do git diff on source. Yeah, I did a lot of cleanup. I reordered things. Those values changed a little bit. All right. Star.gd. Okay. I didn't fully fix the alignment issues, but I improved alignment, cropping bugs, and then lots of cleanup and debug logic. All right, this pull request might be like way out of control. I mean, the goal was to get the initial features of OpenCV in. I think we're at that point. I think I'm willing to say that like dwarp and dskew are not part of that core feature set for OpenCV. I think we fixed alignment. I think we fixed cropping. Error on bad OCR, let's skip that for now. Once we get to the place where I've got at least some of the time it getting above 90%, then I'll start implementing that like waterline and say that anything that gets below that waterline gets rejected. Dwarp, dskew, I'll make that a separate pull request. And I'll probably work on that today, tomorrow-ish. And then I think I will be done with C++. I think I'm getting close to, like I'm actually, if I put on the VR headset now and test this latest code, I wonder how good it is. Like it might be pretty darn good. So I'll probably do that. I'll probably this afternoon just do some VR headset testing. And as long as it's in a pretty good realm of quality, like if it's feeling pretty solid, I may make some tweaks, right? A couple of settings tweaks. Maybe I'll add a couple test cases for myself. And again, just turn a few knobs ever so slightly. But then I think I'll call this pull request done. And then I'll immediately start a new code change to do dewarp deskew. And I think dewarp deskew, plus I already have methods in there for like denoising and doing some other basic OpenCV operations. I think then between dewarp deskew, so maybe some denoising, whatever, I think I can then get the threshold up to above 90% quality. Also that alignment issue where those images were way off from each other, I think I can fix that too. Actually, let's see that. Oh yeah, so hold on. Bbox array order is random. That got fixed. That's done. Crop down to page 1. Yeah, I did all this. And it does in fact improve quality speed. So I know that's there. I meant to look at this earlier. Merge multiple frames. This already works kind of mostly. You see how the quality is for this after we have cropping working. I think actually it does improve. I think good cropping makes this better. We should auto crop all the images after we know what the bounding box is, then tune this to see how many frames we actually need. Or does this step need to happen sooner? What happens if we do this step later? I think this also goes with dewarp deskew. So I'll mark that as in progress. It's mostly done. Accuracy above 90%. I mean, this is kind of more of like an epic. This is the big whole thing that I've been working on. Which once this is done, I think I am done with it for a bit. I may do like the performance boost to see if we can get the speed down, but that's really just, speed boost is just going to be create a bunch of test cases, measure quality, and then go ask Claude to refactor the code to be tighter and faster and make sure the quality doesn't get worse. And as long as that's true, that one's done. And then I think I'm switching back to just Godot stuff. Replay errors in the test harness. Yes, so always save off the 3 to 7 images we grabbed for processing. Yep. If a bug is found, copy paste that folder into the test data folder. Yep, that works. Create a debug script step that runs on local windows that auto pulls every folder from that folder. Yep. Images and replays, OpenCV and OCR, and it's like mostly there. I'll add this down here. We'll say replay OCR steps. Or just like run OCR steps. Yeah, it should then be able to make, I should then be able to make code changes and then quickly run the test suite, perhaps even on a GitHub action. CI/CD parens GitHub actions. Shell script to run everything in one command. This is done. Could be faster. This is already kind of true. Yeah, leave that there. Okay, so replaying errors is in progress. And then what is our dewarp and deskew? I'm going to move that in progress. Those are the 3 things I'm going to work on. Like mainly dewarp, deskew, make sure merging's good, and then improve the test harness. And then hopefully at that point, OCR is above 90%, call that done, do a little bit of cleanup code optimization, and that'll all be its own pull request. So that then gets us there. Cool. So I think, oops, that's it for today. I'm excited. And look at all this debugging. Debugging's so easy now. This is great. And it's so fast. I think I can make it faster. So I think that'll make it more fun. Anyway, thanks for hanging out with me, and we'll chat soon. Bye.